together our second day. We have the program. We have two important lessons. We want first make a reactance design of existing furnaces. This is E. And then we maybe in the afternoon speak about the delta star connection. This is F. There is no strike on Friday. You can regularly use the airplane. It's a question, if you are going earlier to the port, you can probably get an earlier flight. It's every hour an airplane is going from Hamburg to Frankfurt. But you can ask them, what do you think about? The airplane is going at 2 o'clock in the afternoon. If we are leaving the hotel perhaps at 9, we are there at 9:30, and you can ask them to get an earlier flight. So you have more time to change the airplane in Frankfurt. It's a busy airport. This is thinking. Well, this is the point. Last question, discussion, closing remarks. We can do it in the evening. This is not so important. Okay? Let me think. Okay. Our program. I also have. We will have a lot of time. This is my collection of the seminars of the German Steel Company. This paper, yeah? And then we will have a look on it. It's from 2008. We were in Hamburg. This is the presentation of the steel plant. We have calculation of circle diagrams. This is not important. Introduction lecture. We have principles of AC arcs. Yeah, this is physics. Yeah, do you remember this picture? This is physics. We have energy balance of the electric arc, how the energy flows to the wall and to the bath. Can I speak about these? How the energy of the arc is going to the wall or to the bath. We can speak about circle diagrams. You know this by Professor Krüger. How circle diagram is getting. Short circuit operational reactance we spoke about. We have got the paper. We can speak about furnace transformers. This lecture was held by Siemens. We can speak about energy balance of the total arc furnace. But this is very, very difficult. There is given a paper about control. Power control is given by Krüger. power control and isolation model-based control. This is very difficult. It's not good for us. We can speak about power supply of AC arc furnaces. This is important for you. Power supply. Power supply. Flicker. Network disturbances. And this is a typical supply network. Furnace transformer, step-down transformer, network. Yeah. And these are also these are operation points, and this is a circle diagram. This is important. We can speak electric principle of DC furnace, where you have DC furnaces now.
We have one DC furnace in Costco. Yeah.
In Costco you have a DC furnace?
Yeah.
Big?
150 ton.
50 ton. DC furnace, principles of DC furnace. Comparison between AC and DC. What is better? Yeah, comparison. We can speak about construction and operation of DC. You see, this is a good seminar. Yeah. We can speak about twin shell, arc. This is special. We can speak about how the future of AC furnace development, how is the future. You see. And last, forming slack control is written by Krüger. We made some graphite. Okay, this may be, if we have time, we can speak about one or two of these lectures,
Yeah.
if you want. You may have a look into the paper. You can make from some papers photos, yeah?
Yeah.
Okay? Anyone have? Okay.
있지 않나? 단어 없지, 그치? 지금 보여주는 거.
네, 다음은 있습니다.
This is the paper everybody who is in the seminar is getting.
Yeah.
To that time I was the chairman of that seminar. Okay, I also found, this is the print of reactance results and controlling dimensions. With a headline, two headlines.
Yeah.
We do not have this in our manual because I was not possible to give this into the manual because this disappeared and this disappeared. But you see, if you make a paper print, this is coming also with your logo. Okay? Okay. Okay. Now we have point E, reactance design of existing furnaces. There are two possibilities. You start or I start. This is my example. You start with your example or I start with my example.
First time start.
You will start?
Yeah.
Yeah, okay. It's a young boy. He's pushing forward.
Yeah.
Yeah, I like the young people. If I look to my grandchildren, I like to be young. Okay.
수업 때는 그냥
chance.
Okay. Mr. Eon presents. This is your first design?
No, this is extinct extinct design.
It's a ladle furnace, you said, yeah?
Yeah, but this design is EAF, electrical arc design.
Yeah?
Yeah.
Or let's say, may you have a controlling picture, the three-dimensional view.
Yeah.
The
Okay.
controlling picture. Uh-huh.
Yes.
Your design is a triangular system.
Yes.
Yeah.
System. Yes.
Okay.
This one.
Uh-huh. There's no data star connection not necessary.
Yes. This.
Okay.
In a collection.
You used full plated, yeah,
Yes. Copper
Yeah.
plates.
copper plated electrode arms, and you used two flexible cables.
Yes.
Yeah.
Yes. This is two. First
Yeah.
cable. And
Okay.
two
This is
post-
total. Now let's start step by step
Yeah.
on the left side. General data.
Yes, generator. You can see. This.
Neon. 60 cycles per second.
Yes, this is 6 frequency. Twisting.
And it's 11 meters long.
Yeah.
This is Beispiel. X is 11. This is very long. This may be the reason why you have a big reactance. This distance is very good. Yeah? 11 meters. Yeah? And it goes down 6 minus 7 meters long. How many tons?
60.
60 tons?
Yeah.
Uh-huh. And the electrodes are 625.
Yes.
The current, the rated current is 240 kiloamps. This is rated current, yeah?
Yeah.
Mm-hmm. Okay.
Yes.
And then, yeah, this is good, yeah. And now the transformer connection.
Okay. This information is this part.
Oh, let's have a look into the general data. I see there. You see the average current density
Yeah.
is about 5. On the electrode arm it is smaller, 2 kiloamps per millimeter square. Yeah. The electrode have a very low current density.
Yeah.
You see, therefore you also can use electrodes with smaller diameter. 0.18 is a very small rate. 0.18 for electrodes, kiloamp per square millimeter, and for 42 kiloamps you can also go to electrodes. The electrode diameter was 625. You can use 500 millimeter electrodes because this is very low. Yeah. Many people say we can have 0.3 kiloamp per square millimeter. Yeah.
최대한 했던 건가? 0.18은?
이거 말씀이십니까? 아니다, 그거 됐을 거예요.
Oh, this is a very low rate, you see that. But you must look into the paper of the electrode manufacturer. How much is the allowed current density for electrode? Oh, they have this blue.
Okay.
Perhaps we'll look into this paper and find some idea about electrodes. Here. Yeah, diameter. Current is not shown. The current is not shown. Apparent density, that is the mechanical density. Well, more. Here, current carrying capacity.
Yeah.
Yeah, and you have 600 millimeter, and then you can, for AC, use 60 kiloamps, and your current is 40 kiloamps. You can also use 500 millimeter. Yeah. So, go this way for 40 kilo. You can also use 500. Yeah. If you use a 500 millimeter electrode, the current density will be 500 millimeter. Current density will be current to ampere 42 kiloamps divided through P D Quadrat Viertel 42 kiloamp. P D is 500 quadrat millimeter quadrat divided through 4. Well, I will calculate what this means. Do you have a pocket computer? This is 42,000 ampere. 42,000 multiplied with 4 divided through P
Dissolution.
4.21 ampere per square millimeter. It's a little bit higher than this, but you can use 500 millimeter instead of 600 millimeter. 600 millimeter with 600 millimeter electrodes, you can use 60 kilograms. Okay?
Okay.
This is the first impression. Yeah? You give the data for the construction, yes? He is the main constructor, electrical constructor. Yeah? But if you want later use a higher current, then you can use this. But the 600 millimeter electrode is about for bigger furnaces of 80 megawatt. Okay? Okay.
This value is the same.
Yes, I do not know what it is. Current density. It's dependent from country to country. How much is the current density in high current system? The allowed current. I do not know. I'm not expert of this. Maybe that is a good construction. You see also the current density on the electrode arm is small because of there's much copper. Okay. But it is also dependent on the prices. Sometimes 600 millimeter electrodes are cheaper than 500 millimeter electrodes. Maybe, yeah. Because this is very, very often used, the standard diameter. Yeah. Okay. Now we go to the transformer connection. And show the picture.
Yes.
You have tubes.
Yes.
You have tubes.
Two tubes.
Yeah. And you have from the transformer.
Yeah.
There's also the connection out of the transformer is in the triangle.
Yes.
Yeah. I see that. Okay. Okay.
Okay.
Put the picture, and then you have 3 parts in the outside phases. Okay. Yeah. Okay. 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 And the reactance of the transformer connection in the middle phase is higher because it is gone up. Yeah.
Yeah.
But this is seems to be good. Okay. 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 Yeah, close. Please close. And now we want like to flexible cables and see the picture. We have 2 cables.
Yes.
And the cable is what kind of cable you use? Do we have from the manufacturer? Do you have You got dates from the manufacturer, how the GMR is.
Yeah.
Yeah.
Yes.
How many square meters do you have? How many square cross section is 4,500 millimeter for one cable, 4,000 millimeter. This is about this cross section. Yeah, and the GMR is 64. You have 53. Well, this is dependent from the customer.
Yes.
From I do not know who makes today. Where do you get these cables from?
Oh, wait. Okay.
Cables to
Mhm.
Yes, this.
Uh-huh.
This is GMR,
Uh-huh.
cross section.
Uh-huh.
Yes, so I just insert this date.
Uh-huh. These are the days.
Yes, so
And these cables are for current. Do they have the rated current for this cable? They gave you the rated current, allowed current for the cable?
저 시트 보죠.
Uh-huh. Erecting bending radius. You see the minimum bending radius. What that is? You know, this bending radius is this, yes? The minimum.
미니멈.
Whatever pressure, testing pressure, cooling rate. But the current, the allowed current for this cable, do you get that cable from Danieli?
this project is, I don't know.
Yeah?
because-
Yeah.
You get that from Danieli. Is Danieli the manufacturer? But they has Danieli also a table with different construction and what do they say about the current?
전체 화면을 보죠.
Yeah?
아니요, 케이블 메이커가 문제였나?
What is the allowed current for this cable?
Not later.
They come from Italy, yes?
Expression.
Uh-huh. This I cannot find it. The allowed current for this.
Yeah. But we choose the K height. What?
Yeah.
But we choose
Later furnace.
yes. The difference is 6.5.
Yeah.
EF is 4.5.
Yeah. Cable 6.5
Yeah.
ampere per millimeter square
Yeah.
for ladle furnace and for ERF it's 4.5 ampere per millimeter. I'll have a look into my paper. electrode cables 3. I have here 3. 3. And it's allowed 6. And this is a cable from down here again. Okay, now we go back to our. And you have back,
Yeah.
close. We have a flexible 4 point. This is, I think, this is
Yes.
between these. We
Mm.
can accept that. It's between these both. You can also. You can also use a smaller cable. Yeah, these are the allowed current densities if you have a ladle furnace. This is a ladle furnace, yes?
This is
up
yeah.
furnace.
Other furnace.
Yeah, up, yeah.
This is not a ladle furnace?
Yeah. This is electric arc furnace.
This is an AIF.
Yeah.
Okay, okay, this is good. For AIF, this is good. Okay?
Yeah.
You have learned a lot of things during the last months, yes? Yeah? Is that correct?
Yeah.
Yes, learned. He is an expert.
Yeah, and now it's very
A very important man in the company. You see how complex these systems are, yeah? How much knowledge is seen in this paper, yeah? Okay, flexible cables is okay.
Okay. This. Let's
We
put
hold
this
out.
electrode down. You can see the picture. This.
Yeah, okay,
Yeah.
okay,
First.
good. We have 600 millimeter and 500 millimeter. This is a very large construction.
Very.
Do you, what reason you use for the electrode holder? $652, 500. You can only use this. This is a little later. Yeah, this is the AIF. Okay. But for this current, yes?
Yeah.
Okay. This is very large. Very large. And it is your decision, your experience how to use. You see another example. The electrode arms are over triangulated. You know what I mean? Yeah? The reactance in the middle phase is higher than in the outside phases.
Yeah.
Yeah?
Okay.
You see that?
Yeah.
You have this, and this, you can make this distance smaller. This is over triangulated. Yeah? Here we have 841 and you have outside 752. Yeah, you can, and the distance between is 700. Yeah. Yeah.
1000?
Make it, oh no, make it 200 millimeter shorter. 700. Make it 1500. Try to make, yeah, this better. Minus 500, the other also. We will have a look. Also, 8
is
2 7, 7 5 2. It's a little bit smaller.
Yes,
A little bit smaller. Make it 1200.
1200. 1200.
The other.
What?
And
This is little increase.
this is very. There's a low influence, yeah? Canada. I cannot understand what the reason is. Okay. Can you show, make the old data in it? Your old data was 770.
Okay.
And this was, and show the picture. Show the picture and may I have a look into the data? And go to the flexible cables.
Yes.
The flexible cable shows the picture. Yes. Make this value shorter. This value. Go outside. And the no flexible cables. This value in the middle phase. 2. This is the start point is 0, and this is the x coordinate epsilon. Now go back.
Go back.
Go back
Yeah.
and look for the transformer connection.
Okay.
And show the picture.
Okay.
And this length make a little bit smaller.
A little small.
Okay, you understand what I'm doing?
Okay, get
Yeah.
this part.
This one, like 200 millimeter,
200.
848.
Okay, 200.
No, 848.
840.
Yeah, and the other two. And look into the picture. Okay, it's smaller. You see that?
You see?
And it's better. Yeah.
Yeah. Oh,
The total reactance is much better. You see that?
yes. Okay.
You see that? There, this is nearly this. We can also go to 700. Yeah.
700.
700.
700.
And also,
Oh.
oh, you see that?
Yes, this is very.
Yeah? Ah,
그대로네.
아니 줄었습니다 이게.
아니 저기
아
700.
이게 이거는
748.
yeah. And show the picture of the flexible cables.
이렇게.
Yeah, and show the picture of the electrode arms. Yeah, this is the deeper. Yeah, this is a little bit deeper, yeah?
Yeah.
Okay. Can you show the total picture
Okay.
on side view?
Yeah, but this is better.
Yeah, this. A little bit. You see the electrode length is too small.
Yeah.
Yeah, we should rise up
Yeah.
for 200 millimeter. No, too
No,
much.
no, no.
Okay?
Okay.
Controlling picture, side view. Okay,
Okay.
this is good.
This
So,
latest
and
is
this?
good.
This is 1%. Yeah?
Yeah.
Okay. You can see that
Yeah.
you can step by step
Yeah.
make a symmetrical reactance.
Yeah.
You choose the triangle system. It was over triangulated before.
Okay.
There is. Please do not. I will not make any bad mistakes. We say we make bad mistakes. This is imperials. Yes.
Yeah.
Okay. This is very good. And look at controlling dimensions.
Controlling dimensions. Okay.
It's 121 degree, and the diameter is nearly the same.
Yes.
Yeah. And the curve diameter is 2000 for phase B. Is this allowed? The curve diameter 2000 for this flexible cables.
Yeah.
Yeah. Curve diameter. This is. You know what the curve diameter is, yes? This curve diameter is 2000.
This means is
Minimum.
minimum.
Minimum is 800. This is good.
Okay.
This is good. This is good.
중간에 꽤
비상하고.
It's good. This is good.
딱
It's
2000인데
only, yeah, this is good. You can you show me the total system, a picture of the total system on the top view?
Top. Okay.
You see, there's. Okay. Yeah. Yeah. What about this here?
This.
And the connection
Yes.
is the connection.
Just connection.
Yeah, connection against the electrode holder. Yeah.
Yes.
Okay. And this is the start of the electrode holder, and you make. Yeah, these are the flexible cables.
Yeah.
You put it against. So, yeah?
Yeah.
Okay. What is this?
This part is covered.
Is distance from copper?
Yes.
Uh-huh.
This part is just covered.
Uh-huh.
So I
Uh-huh.
insert the
Uh-huh.
date.
열한지문지.
There's not on this side. There's not, but I did.
difference.
This is a little bit different. Yeah.
Yeah.
Can you show me the picture of the flexible cables?
Yes.
Uh-huh.
Yes. You can see the electrode on
Yeah.
this part.
Ah,
This part
this
is.
is the additional part.
Yeah.
How did you construct this? I would not have any.
내가 보자. 그 도면 있지 않나?
Ah,
왜요?
how did you construct this? You're not done nearly. I would like to see how do you construct this. Ah, this is this.
그냥
Yes.
크게 안 보자.
This is like yesterday, we have seen
this
yesterday. Yeah?
this is middle part is different, so I
Yeah.
just input the coordinate.
Yeah.
There's the. Understand that?
Click that away. Click that away. Yeah. Delete this. Make your.
Okay.
Yeah. I do not understand how did you make this construction where you put the flexible cables against. This is not we must weld here. This is a welding piece.
어떻게 연결할 수 있게 진짜?
예?
저 연결가 제대로 안 될 것 같은데.
Did you make?
수치를 어떻게 그런지
I did not know how you. I had no idea to make this. How did you make this? These two little parts.
저 어떻게 만들었어? 아니 수치를 넣었을 거 아니야.
예, 저건 근데 제가 임의로 한 거고요.
임의로 했다고?
예.
임의로 어떻게 했지? 그림이 저렇게 나오는데.
This is
Yeah.
C. I just this is middle.
Yeah.
This is middle point.
Yeah.
So I think just
What part? This is a new part of the electrode. How do you use it in the program?
I just accept this
Yeah.
point. So I want to express this part. In the middle.
Yeah.
Yes, I think this.
I have another idea. I do not think you will make this construction reality
Okay.
because you must weld it. Not so.
Yes.
This is a bad welding situation. You must, if you. I understand. Yeah. To weld this here, this is not very, can be very easy damaged here. How do you think about this? Do you know how we can make this?
Yes,
Do you know?
yeah.
I would think about this.
I just this point. Just
Yeah? Yeah, no? Yes, you can do that,
yeah.
but I would, if I had this problem, I do not have problem. I would take an electrode arm reactor with one part.
Ah.
Yeah, you understand?
Yeah. No.
Electrode arm reactor with one part, with this little part. Yeah?
Yeah.
Yeah?
I understand that.
Yeah.
Yeah. Okay.
Yeah, because these things have different thickness. Yeah, and I would use an electron arm reactor which has only one part, not four parts, only one part. You see?
Yes,
The
yes.
advantages of our program.
Yes, I know. Understand that. Yeah.
Yeah, okay.
Okay.
Will we try to do that now?
Sure.
Well, we have enough time.
Yeah,
whole
yeah,
day.
that's right.
But we can help him. No? 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 Close? Electron arm reactor. In the middle phase. In the middle phase, not there. No, not in the outside phases. Put that away. No. Put that away. We do not want something in the outside phases. A and C.
Yeah.
Put that away.
Okay. So.
No.
No.
It's incomplete. Here. This. Make no conductor. There. No. You are in the outside phase. No conductor.
No conductor.
Yeah.
Yeah.
No conductor in A and C. The conductor would be here.
B.
Yeah?
Yeah.
How long was this conductor? So long?
No. Finish.
300 millimeter?
Yes.
8? 8 is, yeah?
Yeah.
Wide? Thickness? 8 millimeter. It's not complete. And the length? Only one. X. Yeah, and the L is not complete there. That's a mistake. Yeah, okay.
Okay.
Show the picture. What is in the x-axis?
I know. Okay.
Yeah, this is, you see, this is the first step. But we need this.
Okay.
No, here you must go. 300 millimeter. And in epsilon direction. No, only one.
Yeah.
Only one. It's from the side, it's from the top. 300. We are here. At the end of the cables, I do not know, the end of the cables may be here and here.
Okay.
And make this 200 millimeter,
Yeah.
and the thickness is 100 millimeter maybe. And we want to construct this part. We start here. Oh, I must. It's. This is a flexible cable, and this is the part. And here is the electrode holder, and this is this side, and this is this side. Yeah. Yeah, from the top. From the top. And here's the electrode, the flexible cables,
Yeah.
and this is the electrode arm. Yeah, and we start here. It's long 200 millimeter
Yeah.
in X-Richtung, and it is in Y-Richtung 0 and in Z-Richtung 0,
Yes.
and the thickness is 3 wide, 8 is 662
Yeah.
or less, and the wide maybe 200 there. And thickness,
This is just this.
yes.
Yes.
The thickness of copper plate is 10 millimeter. That's not
Yeah.
so important. Now show the picture. This is now connected to the electrode holder. Yeah, now we would like to see. This is better.
Yeah.
This is better.
Yes, I
And
understand.
now you can connect your flexible cables on this.
Yes.
Okay.
Understand.
That you can make at home.
Okay.
But this is better now, yeah?
Mm.
You understand me?
Yeah.
This was an electrode arm reactor with one side, yeah?
Yeah.
And you can use it because you can, the sizes may be different,
Yes.
yeah? Like here, yeah? Okay.
Okay.
Now we have a view of the total system. We should not leave this controlling picture of the total system. No? Three-dimensional view.
Sorry.
Okay. Okay. You must think how to connect the flexible cables on this.
Yes, I
You
understand.
must think about at home, yeah?
Yeah.
Okay, this is very similar to that you have seen it, yeah? From Danieli, yeah? A small piece, yeah? You remember?
Yeah.
좀 이뻐졌잖아.
You see also here, smaller part,
Yes, I
yeah?
understand.
And here a smaller part, yeah?
Similar.
This is a method of making other construction.
Yes, understand. Thank you.
Okay?
Yeah.
Oh, you see that? See that there?
Yes.
Yeah.
Yes. I can see.
Okay.
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 Good.
Now this distance. Let's see back. Top view. The distance is varying. You see? Here and here.
센터
Yes.
포인트이 없는데.
Oh, this is my mistake.
The distance can be constant.
Yes, I know.
Yeah. It's epsilon.
Okay.
Yeah, this.
Just.
So the top view of the total system, yeah. This system is smaller, the distance than here.
Yeah.
You can use the same distance. It's dependent where your hydraulic system is, the situation of the hydraulic. You have, this will be the furnace,
Yeah.
and the electrode hydraulic system may be in this direction. It's dependent. It should be parallel, if possible.
This
That's better.
Yes.
Yeah, it's better.
Yes.
Mm-hmm. Okay. Oh, there's a little mistake now.
Yes, this
Yeah,
yes.
this is from the distance here.
Yes.
You must make this 100 millimeter
Okay.
smaller. Yeah.
여기도
Better.
좀 해야 되겠다.
A little bit better,
Yeah.
but not the best.
네.
Yeah,
That's
better.
good. Yeah.
Okay.
You see, difference of the reactance is 1%.
Yeah.
This is allowed. It's allowed. 1, 2, 3% is allowed.
Okay, 3%.
Yeah.
Okay.
And the electrode length of the middle phase a little bit longer. And you show the controlling picture side view.
Yeah.
Yeah. Yeah,
This
very
is-
small deviation.
Yes.
It's not important. Okay. Any more questions?
Oh, I have a question. Oh,
You are learning this language in the school with a different. How many years do the people, the children in the school learn this?
Korean English?
Yeah, 1 year, 2 years. It's not easy to.
Very easy. Yeah.
Yeah. How many pictures do you have in your? Very much more than in the typical language. We have
Well,
trained.
I think in some general people understand the language in text.
Yeah.
So in this case, one day is perfect to read.
In one day?
Yeah.
The children in school.
Yeah.
And you? If you would learn this new,
No.
you would use 1 week.
Yeah, okay.
Children in school can learn very, very fast.
Yeah.
If I'm playing against my grandboy, and you must remember pictures, I have no chance to win against him. Remembering pictures. Okay.
Oh, okay. I have a question. Remember this?
Oh, this is an answer to your.
Yeah.
This is only for
Level 5.
60, for 50 cycles per second.
Yes, this is reference.
This is my experience, yes.
Yes, this is experience. Oh,
And you added this for 60 cycles per second. Yeah.
yes, I just times
Mhm.
1.2. So I want to know the electrical arc furnace. For
Yeah.
electrical arc furnace, I want to know this value.
Yeah. Yeah. This value for
Ladle
ladle
furnace.
furnace.
Yes. For electrical arc furnace,
Yeah.
I want to know this.
Do you have any experience
This is mid-size furnace.
Yeah.
This is my idea for 50 cycles per second.
Yeah.
And for large furnace, it may be 3 millions.
Yeah.
It's dependent from the size. Yeah. If you have a very large furnace, can you give me the blue book there? The blue book on the left. Yeah, this. These are my publications. We made in '92 new electrode arms for the 400 tons furnace in northwestern Steel, America. This was to that time the biggest furnace, 400 tons. We have 400 tons. This is the old system, and this is the construction of the old system. And we made this, and we thought about the eigenfrequencies of this system. The eigenfrequencies, the mechanical eigenfrequencies, and this is the simulation of the electrode hole and the electrode and the hydraulic system. And you can make measurement. In Germany we make measurements about this. During Christmas time, when the furnace was standing, we make an impact on this, and the response was measured over the total system, and we could see the eigenfrequency of the system. This is the first mode, 3 cycles per second. This is the second mode, this direction, 3.7 cycles per second. This is the third mode in this direction, and this is the fifth mode, in the fourth mode, 5 cycles per second. Yeah? And the middle phase. The outer phases, they are different modes, and you can make a simulation of this, and this is the new current conducting arm for the 400 tons furnace. These were the arms before. You see these tubes. And these arms are long, 10 meters. 10 meters. And the longer the system, the higher the reactance is. And I think this system has 50 cycles per second, more than 3 millions. And if you have a 60 cycles per second, maybe it's 3.6 millions.
It is Arab?
Huh?
Arab?
No, this is United States, Northwestern Steel Empire. To that time, it was the greatest furnace of the world, the biggest furnace of the world. Yeah? And these were the largest copper-plated electrode arms of the world. And before this, they make this current conducting arm in the 130 tons, a chaparral steel, you may say. You see there is a reactor, additional reactor on the transformer side. You see that? You can see that? Okay. And I will show you the picture. If you have a large furnace, this value can be about 3 millions or more, and at 60 cycles per second, 3.6 millions.
Yes.
This was your question. I hope I can give you. There's no standardization in it. This is only experience. The larger the furnace, the higher the reactance. Did you see that? High, low.
Yeah.
Yeah?
This value is the same for EAF.
Yeah. This is a ladle furnace,
Yes.
and
This.
there are no differences between a ladle furnace
Yeah.
and in electric arc furnaces. The supply and the construction is the same, but the ladle furnace is much smaller in most cases. Yeah, smaller. The system is smaller because you put molten steel in it and not cold scrap.
Yes.
If you have a cold scrap system, you need a big volume here. Yeah, a big volume. If you have cold scrap, yeah. But if you have a ladle furnace, you have molten steel. You do not need so much volume. Yeah. But ladle furnace and electric arc furnace
Is similar. This value.
from our construction is the same.
Okay. Thank you.
There are differences in the size. In most cases, ladle furnaces are small. You see? See here. You see, look here. This is a ladle furnace. See that? The volume is small. You see, the electrode arms are small. Yeah. There, from the principles of electrical design, there is no real difference between this, but there's one thing we must know. Yeah. A ladle furnace has always a smooth operation because there's molten steel. And in most cases, if you